Good morning, students. Today we are going to read the lecture number 2 in the topic of DC motor, in the topic of electromagnetism, in the subject of physics O levels. So concentrate yourself. Here we are going to start. The first thing that we are going to read in the lecture is the turning effect on the coil can be increased by. So this is a short question which frequently come in the paper. So concentrate yourself. The turning effect on the coil can be increased by, number one, increasing the current. So increasing the current will increase the turning effect on the coil. Number two, using a stronger magnet. Number three, increasing the number of the turns on the coil. Number four, increasing the area of the coil. A longer coil means higher forces because there is a greater length of the wire in the magnetic field. A wider coil gives the forces more leverage. And number five, inserting a soft iron core within the coil to concentrate the magnetic field lines. So these are the five things which increase the turning effect of a coil. The next thing that we are going to read in the lecture is the back EMF. As soon as the coil of the motor starts to rotate, it behaves like a dynamo. And an induced EMF is set up which opposes the applied EMF. So one thing is applied EMF, and when the coil in the of the motor starts to rotate, behave like a dynamo, and an induced EMF is set up which opposes the applied EMF. This is known as the back EMF. The resistance of the armature coil of a motor is very small. If a large EMF were to be applied, so this is very important point. So if a large EMF were to be applied directly to it, the large current produced may cause the armature coil to burn out. So this is the reason we cannot apply the large EMF. A starter resistance is used in the series with the motor so that the original current is reasonably small. So the original current should be reasonably small so that it cannot be burned out. As the motor speeds up and the back EMF begins to take effect, the value of the starter resistance is reduced. When the motor is running freely, so the resistance will be getting smaller and smaller. So when the motor is running freely, the difference between the applied EMF and the back EMF is equal to the current in the armature coil multiplied by resistance. So look now, EMF applied minus EMF back is equal to current multiplied by resistance. So when a motor slows down, the back EMF decreases. This causes the current to increase. So this is the reason the back EMF will be decreases when the motor slows down, and this causes the current to increase so that it keep it on moving, and so the torque on the armature coil increases and the motor speeds up. Thus the back EMF acts as a regulator and the motor runs at constant speed. The next thing that we are going to read is the working motors. A working motor is more complicated than the simple model described above for the following reasons. So here are the reasons that are actually the differences between the working motor and the motor described above. Number one, instead of a single coil, there is a large number of the coils and a large number of the sectors on the commutators. So the working motor does not have a single coil, it has a large number of the coils. This ensures smoother running. Number two, the coils are wound round the core, which is made up of the thin lamination of the stronger magnetic alloy. The laminations are insulated from each other. The whole of the rotating system is called the armature, and moving coil is known as the armature coil. So this is the second difference. Number three, instead of a permanent magnet, an electromagnet provides the magnetic field. The coil used to excite the electromagnet is known as the field coil. So the working motor does not have a permanent magnet. It is actually having the electromagnet. The purpose of an electric motor is to convert electrical energy into mechanical energy. There are different types of the motor depending upon how the coils in the motor are wound. So it is depending on the coil, how it is actually winding. So that actually creates the difference between different types of the motors. Number one is series wound motors. Here the field coil is in the series with the armature coil, and so the current is the same in both coils. Since the torque on the armature depends upon the current square, there is a large initial torque. So this kind of the motor is actually required in the heavy machinery. These motors are very useful as starter motors in trains, cars, etc. The next type of the motor is shunt wound motors. As the name implies, the field coil and the armature coil are in parallel. So the sign of this kind of the motor is the field coil and the armature coil are in parallel. The current in the field coil stays constant and the current in the armature coils varies. So this is another point to be remembered. The current in the field coil stays constant and the current in the armature coil varies depending upon the speed of the motor. So more the speed, more will be the current, and less the speed, less will be the current. Due to the back EMF, the motor is more or less self-regulating and will run at constant speed. These motors are used to drive machines such as the lathes in the factories and are used in the vacuum cleaners, refrigerators, etc. in the homes. So they are actually self-regulating machines. The next type of the machine is compound wound motors. These motors are a combination of the other two types and the attempt to retain the advantages of the both. So this is a most modern motor which is having the features of the two motors. Every time you put your washing into the washing machine or use a vacuum cleaner, you are using an electric motor. Your car also uses an electric motor or get it started. For these sort of the uses, motors need to be made as powerful as possible. Here are some of the ways that can be used to make a motor more powerful. So this is the figure and here are the ways to make the motor more powerful. Number one, a large current should be used. So more the current, more will be the powerful the motor will be. Number two, as many turns as possible should be put on the coil. So more the turns on the coil, more powerful will be the motor. Next is more than one coil can be put on the rotor. Each coil then experiences a force, so the total force turning the motor is larger. So this is another way to make the motor powerful. The coils can be wound on an iron core to increase the magnetic field. So this is another way that coils can be wound on an iron core so that it actually concentrates the magnetic field lines. So more powerful will be the motor. We are going to read a very short question which frequently come in the paper. That is, some causes of the loss of the energy are: number one, how the energy actually lost in during the running of the machines. Number one, kinetic energy of the moving parts. Number two, kinetic energy of the water. It has a kinetic energy as well as the potential energy when it reaches the top. Number three, heat produced in the windings and bearings. And number four, sound produced. So this is how the heat energy, this is how the energy is lost in running of the machines. Next thing that we are going to read is the power of a motor. The power output of a small motor can be measured by allowing it to raise a mass through a given height. So the mass should be known and height should also be measured. The motor drives a shaft around which a string attached to the mass is wound. The mass is adjusted until the motor raises it at more or less constant speed. So The motor should raise the mass with a constant speed, so the mass should be adjusted. Then the time t for the mass to rise through a measured height is taken, and power output will be equal to mgh over t. So where m is in kg and h is in meter and t is in seconds. That we are going to read in the lecture is very important, that frequently come in the paper. So these are actually the differences between the motor principle and the generator principle. So concentrate yourself. The motor principle is electrical energy plus magnetic energy forms mechanical energy. That is, motion mechanical energy is obtained from a current carrying conductor placed in a magnetic field, whereas the principle of the generator principle is mechanical energy plus magnetic energy forms electrical energy. That is, current, that is electrical energy, is induced by moving a conductor in a magnetic field such that the former cuts the magnetic field. The next difference is direction of the motion can be determined using Fleming's left hand rule. So this is Fleming left hand rule. All three fingers should be at right angle to each other. So the first finger, that will be field magnetic. So this is the first finger, and this is the second finger. It will direct in the direction of the current, and thumb will show the direction of the induced motion. Okay, whereas in the generator principle, direction of the induced current can be determined using the right hand principle. So this is the right hand principle. All three fingers should be in the 90 degree with each other. So first finger will be in the direction of the field magnetic. The second finger will be in current induced, and the thumb will point in the direction of the motion. Okay, the next is, the difference is, here is the motor principle, here is the generator principle. So the application of the motor principle is the motor, that is moving coil galvanometer, ammeter, moving coil loudspeaker, whereas the generator principle is applied in the generators, moving coil microphones, and the transformers. So this was the lecture, students. I hope so this will be much more easier for you to understand now. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.